In this video, we review test 1. Number 1, the smallest whole number is 0. Number 2, the smallest prime number is 2. Number 3, find the GCF for 4 and 20. GCF is the initials for greatest common factor. This is the special case number 1. 4 and 20. The smaller number 4 is a factor of 20. 20 is a multiple of 4. So the GCF is the smaller number equals 4. Number 4, find the least common multiple of 5 and 15. This is special case number 1. 5 is a factor of 15. 15 is a multiple of 5. So the least common multiple is the bigger number, 15. Number 5, find the GCF for 4 and 7. Since 4 and 7 are mutually prime, those two numbers have no common prime factor. The only factor of 4 and 7, the only common factor of 4 and 7 is 1. So the GCF is 1. Number 6, least common multiple of 3 and 7. 3 and 7 are mutually prime. The least common multiple of two mutually prime numbers is their product. So the LCM here is 3 times 7, 21. Number 7, find the GCF for 18 and 12. This is not a special case number 1 or special case number 2. So we are going to apply the 3-step procedure for finding GCF. Step 1, we prime factor both 18 and 12. 18 equals 2 times 3 times 3. 12 equals 2 times 2 times 3. Step 2, bubble common factor. 2 and 3 are common factors of 18 and 12. Step 3, multiply the two common factors. GCF equals 2 times 3 equals 6. Number 8, find the least common multiple for 18 and 12. Not a special case number 1, not a special case number 2 either. So we need to apply the 3-step procedure. Step 1, prime factor both numbers. Step 2, bubble. I use the color of red. Bubble the common factors in red and then bubble the leftover factors in green. Step 3, copy all the factors in the bubbles. But if the factor is common, we only copy it once. So we have 1, 2 here, common factor 2, common factor 3. This 3 is the leftover factor. This 2 is the leftover factor. We multiply them together, we have 36. 36 is the smallest common multiple of 18 and 12. Number 9, prime factor an integer, 450. We put 450 on the big L. Since 450 has the last digit equals 0, we know if the last digit of the number is 0 or 5, then the number is divisible by 5. So we divide 450 by 5. We have 90. 90 also has the last digit as 0. So we know 90 is divisible by 5 as well. Divide 90 by 5, we have 18. 18 is even. It is divisible by 2. Divide 18 by 2, we have 9. 9 equals 3 times 3. So 450 equals 5 times 5 times 2 times 3 times 3. That's the prime factorization of 450. Number 10, reduce a fraction. Numerator 10, denominator 12. They have GCF 2. Divide both top and bottom by 2. Numerator becomes 5, denominator becomes 6. 5 over 6 is the reduced form of 10 over 12. Number 11, convert a mixed number to its equivalent improper fraction. Improper fraction is a fraction whose numerator is bigger than the denominator. So what we can do is I can color the parts. I'm going to color the denominator in green. The whole number part is 8. So we are going to keep the denominator 3. Use the whole number part 8, multiply by the denominator. 8 times 3, 24. Add the product to the numerator 2. 24 plus 2 is 26. 26 over 3 is the improper fraction. Number 12, divide a fraction by a fraction. First step, keep change flip. Keep the first fraction 1 over 3. Change the division to multiplication. Flip the second fraction 6 over 1. My procedure for multiplying two fractions is vertical, vertical, diagonal, diagonal, and then multiply across. So you can see this diagonal direction. Right top, left bottom. The two numbers 6 and 3, they have a common factor 3. GCF is 3 actually. And we can divide both 6 and 3 by 3. Then 6 becomes 2. 3 becomes 1. So the two fractions are simplified as 1 over 1 times 2 over 1. Multiply cross, 1 times 2 is 2, 1 times 1 is 1. The result is 2. Number 13, multiply two fractions. 2 over 7 times 3 over 10. Vertical, vertical, we have nothing to reduce. Diagonal, right top, left bottom. The two numbers have no common factor. Left top, right bottom, 2 and 10. These two numbers have a common factor 2. So we can divide both 2 and 10 by 2. Then 2 will become 1, 10 will become 5. The two fractions become 1 over 7 times 3 over 5. Multiply cross, 1 times 3 is 3, 7 times 5 is 35. 3 over 35 is the product. Number 14, take the sum of two fractions. The two fractions have no common denominators. The two denominators are 4 and 12. We need to find the least common denominator. Least common denominator of the two fractions is the least common multiple of the two denominators. This is the special case number 1. 4 is a factor of 12. 12 is a multiple of 4. So the least common multiple is the bigger number 12. We need to modify the first fraction. The first fraction 1 over 4. Both top and bottom multiply by 3. We have 3 over 12. 3 over 12 plus 5 over 12. Keep the bottom, solve the top. 3 plus 5 is 8. 8 over 12 is reducible. Numerator 8, denominator 12 have GCF 4, so we multiply both top and bottom by 4. We could reduce the fraction as 2 over 3. 2 over 3 is the answer. Number 15. The two fractions are 4 over 7 and 1 over 7. Subtraction. The two fractions have the same denominators, so we keep the denominator, solve the top. Denominator is 7. The numerator would be 4 minus 1, 3. 3 over 7 is the difference. Number 16. 8 over 7 minus 2 over 9. The two denominators are 7 and 9. Their least common multiple is their product. 7 times 9 equals 63. So the least common denominator is 63. We need to convert or rewrite both fractions as their equivalent fractions with denominator 63. To do that, the first fraction, both top and bottom, multiply by 9. Second fraction, both top and bottom, multiply by 7. Then the first fraction becomes 72 over 63. Second fraction becomes 14 over 63. Once the two fractions have the same denominators, keep the bottom, solve the top. 72 minus 14 gives 58. The difference of the two fractions is 58 over 63. How do we know this fraction is reduced already? Because 63 equals 3 times 3 times 7. The prime factor of 63 are 3 and 7. The numerator 58 is not divisible by 3, is not divisible by 7 either. So we know 58 and 63 have no common prime factor. 58 over 63 is already reduced. Number 17, adding decimals. We need to line up the two numbers. Let me write it here. 3.28 plus 7.609. When we add two decimals, we need to line up their decimal points. We can see we have 3 digits to the right of the decimal point in the second decimal. We only have 2 digits to the right of the decimal point in the first decimal. So we can put a 0 here to hold a place. And then we add them. 0 plus 9, 9. 8 plus 0, 8. 2 plus 6, 8. Bring down the decimal point. 3 plus 7, 10. So the addition of the two decimals here is 10.889. Subtraction. When we subtract decimals, we line them up. Line them up to make sure their decimal points are aligned. 2.335. We put a 0 here to hold a place. And make sure when we add or subtract, make sure their decimal points are aligned. For subtraction, it's more complicated. We can see the thousandth. 0 is less than 5, so we have to borrow 10 from 9. Borrow 10 from 90. So here you got a 80. 9 becomes 8. 0 becomes 10. 10 is bigger than 5. 8 is bigger than 3. 6 is bigger than 3. 5 is bigger than 2. So we are ready to subtract. 10 minus 5 is 5. 8 minus 3 is 5. 6 minus 3 is 3. Bring down the decimal point. 5 minus 2 is 3. So the difference of the two decimals is 3.355. Subtraction with decimals is more complicated than addition. It just takes practice. Be careful when you borrow. Number 19, multiply. When we multiply decimals, the way we align the two decimals is different. When we multiply decimals, we need to make sure the last digit, the last non-zero digit of the two decimals are aligned. 2.8 times 8.1. When we put them vertically, we need to make sure the last one non-zero digit is aligned. The decimal points happen to be aligned here, but that's coincident. When we multiply again, we need to line up the last non-zero digit. And then ignore the decimal point. Multiply the two numbers as usual, like whole numbers. 28 times 81 gives you 2,268. And then we're gonna place the decimal point. Since in the first decimal, there's a one decimal place, there's a one digit to the right of the decimal point. In the second decimal, there's also one digit to the right of the decimal point. 1 plus 1 equals 2. Then we should move the decimal point to the left twice in the product. The multiplication of the two decimals is 22.68. 22.68. Number 20. Divide the decimal by another decimal. Here 74.7 is the dividend, 5 is the divisor. When we apply long division to divide with decimals, we want the divisor be a whole number. And this problem is easier because the divisor is already a whole number. So I can show you how do we long division here. We put the dividend under the division symbol, 74.7. Put the divisor to the left of the division symbol. 5 goes into 7 one time. Remainder is 2. Bring down the next digit, 24. 5 goes into 24 how many times? 4 times. Remainder is 4. We bring down the next digit, 7. We have a 47 right now. Let's see how many times could a 5 go into 47? 9 times. Remainder is 2. So we need to bring down another digit because we want to divide it completely. We actually have no digit in the dividend anymore. But look at the dividend, 74.7. We could put a 0 here without changing the value of the decimal. Then we can bring down the 0 when we need it. 5 goes into 20 4 times. Now we have the remainder 0. You divide completely when the remainder is 0. The quotient, the number above the long division symbol, you see 1494. Yeah, the last thing we do is to place the decimal point right above the decimal point in the dividend. So the quotient is 14.94. 14.94 is the quotient. Number 21, true or false. We need to determine if the inequality here true or false. This is the inequality. Right hand side is 21, left hand side is an expression. We need to simplify or evaluate the left hand side. Follow the correct order of operations. We're gonna evaluate the quantity in the parentheses first. Inside the parentheses, the blue part, we have 5 minus 6. That gives you -1. And then we see what's inside the bracket. In the bracket, we have 6 plus -1. That is 6 minus 1, which is 5. 4 times 5 gives you 20. Left hand side is 20, right hand side is 21. 20 is bigger than or equal to 21 is a false statement. So the original inequality is false as well. Number 22. Let's go over the rules for the sign of a product first. The product of x and y. The two factors are x and y. If both of them are positive, the multiplication is positive. If both of them are negative, then the multiplication is positive as well. If one of them is positive, the other is negative, means the two factors have opposite signs, then the multiplication is negative. With that rules in your head, let's determine. Let's see, a times b times c squared. A is positive, B is positive, that is given. And what's the sign for C square? C is a negative. C square is C times C. C is a negative, C is a negative, C times C. The two factors have the same sign. So C square is a positive. Square is never be negative. So C square is a positive. All the three factors are positive. The product is positive as well. So the sign for this expression is positive. Number 23. Simplify or evaluate the expression. Please excuse my dear Aunt Sally. We go from the parentheses. Inside the parentheses, we have 11 minus 4 times 6. Multiplication before subtraction. 4 times 6, 24. 11 minus 24, negative 13. So we have a negative 13 right here. 10 square. 10 square is a power. Base is 10. Exponent is 2. We use the base 10 twice in the product. It gives us 100. So we have 100 plus 9 times 7. That is not 9.7, by the way. That is 9 times 7. 9 times 7 is 63. And minus 13. When the expression only contains addition and subtraction, we go from the left to the right. 100 plus 63, that is 163. Minus 13 gives you 150. Number 24, evaluate an expression. The expression is 9x squared minus 4y. For x equals 3, y equals negative 4. So I always put a parenthesis to hold the places for the variables first. You can see in the solution. I use the parentheses in red to hold the place for x. Use the green parentheses to hold the place for y. And then we put value of x, which is 3, in the red parentheses. Put the value of y, negative 4, in the green parentheses. And then we evaluate. Exponentiation go first. 3 squared is 9. 9 times 9 is 81. Minus 4 times negative 4. Negative 4 times negative 4 gives us a positive 16. 81 plus 16 equals 97. Regarding 25 to 29, you are required to remember those formulas. So pause the video here and take time to remember those formulas. I guarantee you, if you remember those formulas, you will be able to figure out the answers for those 5 problems. As a practice, let's look at a set. Here. Let me see, where's my set here? Give me 1 second, let me find. Yeah, this set. Number 1, commutative property. We need to find or identify the example that corresponds to the given property. Commutative property. So look at the A, B, C, D. The answer is D. In D, I highlight 7 plus 1 inside the parentheses as blue, 8 as green. So you can see the equation shows the blue and the green are interchangeable in the addition. So that is an example for commutative property. Part A is identity. 0 is the additive identity. Part C actually is associative property. Part B is a false. The answer itself is a false. The equation is not true. Number 2, we need to find an example for associative property. The answer is A. 3 and 4 added together, and then plus 7 is the same with 3 plus the addition of 4 and 7. Part C is additive identity. Part B actually is commutative property. 3 plus 4, 4 plus 3 are equal. That is a commutative property actually. Part D itself is a false statement. Number 3, inverse property. The answer is C. Look at the bubble. C, we have the blue and the green. The two numbers are reciprocal, or they are multiplicative inverse. If the two numbers are reciprocal, they multiply to 1. 1 is the multiplicative identity. What happened to A, B, and D is those equations are false. Okay, A, B, and D, if you look at them closer, none of them is correct. They are all false statements. Number 4, identity property. We have two identities. Additive identity is 0. Multiplicative identity is 1. So the answer is B. B is the better example to display or illustrate the identity property. Additive identity is 0. 2x plus 0 is 2x. D is closer, but not as good as B. C is false. A is true, but it doesn't show you the identity property. Number 5, the answer is B. Coefficient of the parenthesis is -5. You distribute with the -5. -5 times x is -5x. -5 times y is -5y. That's the only correct answer. So pause the video or repeat the parts that you need more time to understand. The last problem, 5x plus 4x plus 2x minus 7x. We need to simplify the expression by combining like terms. Let's recall the definition for like terms. Like terms are terms whose variable parts are exactly the same. Those are 4 terms. We have 4 terms here. Their variable parts are the same, x. So they are all like terms. We combine like terms by combining their coefficients. Coefficient of 5x is 5. Coefficient of 4x is 4. Coefficient of 2x is 2. Coefficient of -7x is -7. 5 plus 4 plus 2 minus 7 is 4. So the result is 4 times x. After we simplify, the answer is 4 times x. I know I go over those problems quite fast, but this is a recorded video. You could always pause and repeat that part. Please email me if you have any questions. Thank you for watching.